Hello everyone, welcome back to your YouTube channel Mathematics for Everyone. In this video, we take more important questions relating to expansion of determinants which belongs to the previous CBSE board papers. Let us take first question. Prove that determinant b plus c whole square a square then b square c plus a whole square b square then c square a plus b whole square is equal to 2abc is equal to 2abc into a plus b plus c whole cube. Prove left hand side determinant b plus c whole square a square then b square c plus a whole square b square c square a plus b whole square operating c1 is equal to c1 minus c3 then c2 is equal to c2 minus c3. Therefore left hand side is equal to c1 minus c3 b plus c whole square minus a square then 0 c square minus a plus b whole square. Next, c2 minus c3 0, c plus a whole square minus b square, c square minus a plus b whole square. Then last is a square, b square, a plus b whole square. Taking a plus b plus c common from column C1 and C2. Therefore, left hand side is a plus b plus c whole square into determinant b plus c minus a 0 c minus a minus b then 0 c plus a minus b c minus a minus b then a square b square a plus b whole square. Then operating R3 is equal to R3 minus R1 minus R2. We get is equal to a plus b plus c whole square R1 is as it is b plus c minus a 0 a square R2 is same 0 c plus a minus b b square then R3 becomes minus 2b minus 2a to AB. Then we operating multiply C1 by A and C2 by B. We get is equal to A plus B plus C whole square over AB. We have multiply and divide by AB. Therefore, we shall multiply C1 by A. It will be AB plus AC minus A square, 0 minus 2AB. Then C2 by B is 0, BC plus AB minus B square minus 2AB, A square, B square 2AB. Then operating C1 is equal to C1 plus C3 and C2 is equal to C2 plus C3. We get left hand side is A plus B plus C whole square over AB into AB plus CA, B square 0, then A square BC plus AB 0, then A square B square 2AB. Then taking common A from R1 and B from R2, 2AB from R3, Therefore, left hand side is A plus B plus C whole square over AB into AB 2AB into. From first we have taken A common, B plus C, A, then B common, B, C plus A, B, 0, 0, 1. Then expanding by row R3, we have this AB cancelled, 2AB into A plus B plus C whole square, 0 minus 0 plus 1 into B plus A into C plus A is BC plus AB plus C square plus AC minus AB. This AB will be cancelled. From this we shall take C common. 2ABC into A plus B plus C whole square into A plus B plus C is equal to 2ABC into A plus B plus C whole cube, which is equal to right hand side, hence proved. Second question, solve determinant A plus X, A minus X, A minus X, then A minus X, A plus X, A minus X, a minus x, a minus x, a plus x is equal to 0. Solution, we have determinant a plus x, a minus x, a minus x, a minus x, a plus x, a minus x, then a minus x, a minus x, a plus x is equal to 0. Operating on R1, operating R1 is equal to R1 plus R2 plus R3. We get determinant 3a minus x, 3a minus x, 3a minus x, then second row is same, third row is also same, a minus x, a minus x, a plus x is equal to 0. Taking 3a minus x common from row R1, we get 3a minus x into 1, 1, 1, a minus x, a plus x, a minus x, then a minus x, a minus x, a plus x is equal to 0. Operating C2 is equal to C2 minus C1, C3 is equal to C3 minus C1. We get 3a minus x. Determinant. First column will become 1, a minus x, a minus x. Second will become 0, 2x, 0. Third will become 0, 0, 2x is equal to 0. Expanding by first row R1, we get 3a minus x into 1 into 4x square minus 0 plus 0 is equal to 0. 4x square into 3a minus x is equal to 0. Either 4x square is 0 or 3a minus x is 0, which implies x is 0 or x is equal to 3a. Therefore, answer is x is equal to 0, 3a. Question third. Solve x plus a, determinant x plus a, x, 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 x plus a, x, then x, x, x plus a is equal to 0. Exactly in the same way as we have done second question, same steps you will do as we have done in the previous. First of all, you will operate R1 is equal to R1 plus R2 plus R3. Then you will take, in the same way, you will take 3x plus a common. Then you will operate C2 is equal to C2 minus C1, C3 minus C1. And similarly, you will expand by first row. And answer you will get here a is not equal to 0. Answer is x is equal to minus a by 3. So it's a practice question which is exactly same as the previous question. Then fourth question. Solve determinant x minus 2, 2x minus 3, 3x minus 4. x minus 4, 2x minus 9, 3x minus 16, x minus 8, 2x minus 27, 3x minus 64 is equal to 0. Solution: we have determinant x minus 2, 2x minus 3, 3x minus 4, x minus 4, 2x minus 9, 3x minus 16, x minus 8, 2x minus 27, 3x minus 64 is equal to 0. Then you will operating on C2 is equal to C2 minus twice C1, and C3 is equal to C3 minus 3 into C1. You will multiply C1 by 2, then subtract from C2, then multiply C1 by 3, subtract from C3. Therefore, we have C1 is same x minus 2, x minus 4, x minus 8, C2 becomes 1 minus 1 minus 11, C3 becomes 2 minus 4 minus 40 is equal to 0. Now operating R2 is equal to R2 minus R1. You will subtract first row from second, and then first row from third row. So we get determinant x minus 2, 1, 2, minus 2, minus 2, minus 6, then minus 6, minus 12, and minus 42 is equal to 0. Expanding by first row R1, we get x minus 2 into 84 minus 72 minus 1 into 84 minus 36 plus 2 into 24 minus 12 is equal to 0, which will give you 12 into x minus, therefore 12 into x minus 2 minus 48 plus 24 is equal to 0. 12x minus 24 minus 24 is 0. Therefore 12x minus 48 is equal to 0. 12x is 48. Therefore x is equal to 48 by 12, 4, which will give you x is equal to 4. So answer is x is equal to 4. That's all. In the next video, we shall take more very important questions from previous CBSE board question papers. So please don't forget to like, share, comment and subscribe Mathematics for Everyone to see more important videos. Thank you. See you in the next video.